Do you want to learn real hacking skills, the same ones used by professionals, but in a safe and legal way? You're in the right place. I'll teach you how hackers think and how to protect yourself step by step. From setting up your own hacking lab to using tools to practicing on safe, vulnerable apps, I'll guide you through it all. So if you want to master ethical hacking and cybersecurity, subscribe now and turn on notifications. It won't cost you anything, but it could start your career in security. Welcome to Cyber Guru. Let's hack the right way. Today is an introductory class in which I will only talk about the concepts no practical work. So today I'm going to teach you hacking concepts, ethical hacking concepts, and AI hacking methodologies and frameworks. Let's start with what is hacking. Hacking refers to exploiting system vulnerabilities and compromising security controls to gain unauthorized or inappropriate access to a system's resources. Now, get forward to who is a hacker. A hacker is someone who breaks into a computer system or network without authorization. Their goal can be to destroy data, steal sensitive information, or launch malicious attacks. Hackers are usually very intelligent individuals with strong computer skills. Many of them are skilled programmers or engineers who know how to discover hidden vulnerabilities inside a system. They often enjoy learning different programming languages and exploring the inner workings of both software and hardware. For some hackers usually fall into one of the following categories according to their activities. Script kiddies. Script kiddies are unskilled hackers who compromise systems by running scripts, tools, and software developed by real hackers. They usually focus on the quantity rather than the quality of the attacks that they initiate. They do not have a specific target or goal in performing the attack and simply aim to gain popularity or prove their technical skills. White hat hackers. White hats or penetration testers are individuals who use their hacking skills for defensive purposes. These days, almost every organization has security analysts who are knowledgeable about hacking countermeasures, which can secure its network and information systems against malicious attacks. They have permission from the system owner. Black hat hackers. Black hats are individuals who use their extraordinary computing skills for illegal or malicious purposes. This category of hacker is often involved in criminal activities. They are also known as crackers. Grey hat hackers. Grey hats are the individuals who work both offensively and defensively at various times. Grey hats might help hackers to find various vulnerabilities in a system or network and, at the same time, help vendors to improve products, software or hardware by checking limitations and making them more secure. Blue hat hackers. Blue hats are contract-based cybersecurity professionals hired by organizations to evaluate systems or software for vulnerabilities. They conduct security assessments, penetration testing, and vulnerability analyses to ensure that weaknesses are addressed before malicious actors could exploit them. Red hat hackers. Red hats adopt aggressive tactics such as black hat hackers with the intent of neutralizing threats before damaging resources. They not only identify and report vulnerabilities, but also take active measures to destroy black hat activities, often going beyond mere defense to prevent security breaches. Their approach is more proactive, similar to white hat hackers, but they do not follow ethical rules to take down. Green hat hackers. Green hat hackers are individuals motivated by the desire to become skilled professionals in the field of cybersecurity. They often spend time studying and practicing ethical hacking, aiming to contribute to security efforts rather than causing harm. Suicide hackers. Suicide hackers are individuals who aim to bring down critical infrastructure for a cause and are not worried about facing jail terms or any other kind of punishment. Suicide hackers are similar to suicide bombers who sacrifice their life for an attack and are thus not concerned with the consequences of their actions. What is ethical hacking? Ethical hacking is the practice of employing computer and network skills in order to assist organizations in testing their network security for possible loopholes and vulnerabilities. White hats, also known as security analysts or ethical hackers, are the individuals or experts who perform ethical hacking. Nowadays, most organizations, such as private companies, universities, and government organizations, are hiring white hats to assist them in enhancing their cybersecurity. They perform hacking in ethical ways with the permission of the network or system owner and without the intention to cause harm. Ethical hackers report all vulnerabilities to the system and network owner for remediation, thereby increasing the security of an organization's information system. Ethical hacking involves the use of hacking tools, tricks, and techniques typically used by an attacker to verify the existence of exploitable vulnerabilities in system security. Today, the term hacking is closely associated with illegal and unethical activities. There is continuing debate as to whether hacking can be ethical or not, given the fact that unauthorized access to any system is a crime. Consider the following definitions. The noun hacker refers to a person who enjoys learning the details of computer systems and stretching their capabilities. The verb to hack describes the rapid development of new programs or the reverse engineering of existing software to make it better or more efficient in new and innovative ways. The terms cracker and attacker refer to persons who employ their hacking skills for offensive purposes. The term ethical hacker refers to security professionals who employ their hacking skills for defensive purposes. Most companies employ IT professionals to audit their systems for known vulnerabilities. Although this is a beneficial practice, crackers are usually more interested in using newer, lesser known vulnerabilities, and so these by-the-numbers system audits do not suffice. A company needs someone who can think like a cracker, keep up with the newest vulnerabilities and exploits, and recognize potential vulnerabilities where others cannot. This is the role of the ethical hacker. Ethical hackers usually employ the same tools and techniques as hackers, with the important exception that they do not damage the system. They evaluate system security, update the administrators regarding any discovered vulnerabilities, and recommend procedures for patching those vulnerabilities. The important distinction between ethical hackers and crackers is consent. Crackers attempt to gain unauthorized access to systems, while ethical hackers are always completely open and transparent about what they are doing and how they are doing it. Ethical hacking is therefore always legal. Let's move into a very modern topic, AI-driven ethical hacking. We all know that artificial intelligence is changing the world, and cybersecurity is no exception. Hackers are already using AI to make their attacks smarter and faster. For example, they use it to automate phishing emails, to generate malware that adapts on the fly, and to scan for weaknesses at massive scale. That means defenders, like us, must also use AI to stay one step ahead. So what exactly is AI-driven ethical hacking? It's the use of artificial intelligence and machine learning technologies to enhance the work of ethical hackers. Think of it as adding a high-powered assistant that helps you collect data, spot patterns, and even generate test cases. It doesn't replace the human hacker, but it makes them faster, more accurate, and more efficient. Let's look at some examples. AI can automate reconnaissance by scanning public sources and identifying hidden assets. It can analyze vulnerability scan results and highlight the issues that are truly dangerous instead of overwhelming you with false positives. AI-guided fuzzers can generate smarter test inputs that are more likely to uncover bugs. Some tools even use natural language models to draft penetration testing reports, saving hours of manual writing. Now, why should we care about this? The benefits are clear. AI improves efficiency because it handles repetitive and time-consuming tasks. It improves accuracy by reducing human error and better prioritizing real risks. It scales beautifully so you can test large and complex attack surfaces more quickly. And it's cost effective because human experts can spend their time on high value analysis instead of boring manual work. But we also need to be realistic about the limitations. AI can make mistakes. It can hallucinate or flag issues that don't really exist. The quality of its output depends entirely on the quality of its training data. Attackers can even try to trick AI systems, which is called adversarial machine learning. And of course, we must respect legal and ethical boundaries. For example, an AI system that generates phishing emails should only ever be used in a controlled, authorized simulation. That's why the golden rule is always keep a human in the loop. AI can suggest, but the ethical hacker must decide, confirm, and act. So the takeaway is simple. AI-driven ethical hacking is not about replacing human hackers. It's about making them smarter, faster, and more capable. The strongest defense will always come from combining the power of AI with the creativity and judgment of skilled professionals. Now let's explore how AI-driven ethical hacking actually helps ethical hackers in their day-to-day work. Artificial intelligence doesn't replace ethical hackers. Instead, it empowers them. By leveraging AI technologies, we can increase efficiency, accuracy, and scalability, while also keeping pace with the growing sophistication of modern cyber threats. Here are the main ways AI supports ethical hackers. First, automation of repetitive tasks. Instead of manually scanning for vulnerabilities, monitoring network traffic, or digging through endless logs, AI can automate these processes. That frees ethical hackers to focus on the more complex, human-driven aspects of testing, like creative exploitation, strategy, and system hardening. Second, predictive analysis. AI models can study past attacks, recognize patterns, and even predict future vulnerabilities. This allows ethical hackers to move from a reactive approach to a proactive one, fixing issues before an attacker can exploit them. Third, advanced threat detection. AI-driven tools can catch subtle or previously unknown threats, including zero-day vulnerabilities that traditional scanners might miss. Using deep learning and anomaly detection, they flag even the smallest deviations in behavior that could signal compromise. Fourth, enhanced decision making. AI doesn't just collect data, it processes and interprets it. By giving recommendations, risk scores, and prioritization, AI helps ethical hackers decide where to focus their efforts and how to allocate limited resources. Fifth, adaptive learning. Unlike static tools, AI systems evolve. They learn from new attack patterns and continuously update their detection methods. That means as attackers innovate, defenders also stay sharp. Sixth, enhanced reporting. Writing reports is often time-consuming. AI can generate clear, structured, and evidence-backed reports on vulnerabilities and risks. This helps organizations understand the severity of issues and act quickly while saving hackers hours of manual documentation. Seventh, simulation and testing. AI-driven tools can simulate real-world cyber attacks at scale, stress testing systems in ways that mirror actual adversaries. These simulations reveal weaknesses that might only appear under active attack conditions. Eighth, scalability. Large organizations may have thousands of devices, apps, and servers. AI allows ethical hacking efforts to scale across this vast infrastructure more efficiently than any human team could alone. Ninth, continuous monitoring. Instead of waiting for the next penetration test, AI enables ongoing surveillance of systems. Vulnerabilities and threats can be flagged in real time, not just during scheduled assessments. And finally, adaptive defense mechanisms. As hackers invent new techniques, AI systems can update themselves to detect and block those new tactics. This keeps security measures dynamic and resilient. So in summary, AI-driven ethical hacking is like having a smart, tireless assistant. It automates the boring tasks, predicts future risks, detects advanced threats, and helps ethical hackers scale their impact, all while continuously learning and adapting to the ever-changing threat landscape. Let's now talk about one of the most exciting areas in cybersecurity, ChatGPT-powered AI tools for ethical hackers. These tools build on OpenAI's ChatGPT model and integrate natural language processing, machine learning, and automation. The result is a new generation of assistants that helps security professionals work faster, smarter, and more effectively. So how do these tools actually help? First, data collection and configuration. They can pull data from social media, websites, forums, and public databases, giving ethical hackers a richer view of the attack surface. Second, real-time assistance and automation. ChatGPT-powered tools can automate repetitive tasks like scanning for vulnerabilities, analyzing threats, and even generating first draft reports. That means less time on routine work and more time on creative testing. Third, integration with threat intelligence databases. By combining scan results with live threat intelligence, these tools give hackers valuable context. Instead of just saying, here's a vulnerability, they can explain how it connects to active exploits seen in the wild. Now, let's look at some concrete examples. Shell GPT, an AI assistant for the command line, it can generate shell commands, complete them, write secure code snippets, add documentation, and even answer technical questions right inside the terminal. AutoGPT, a task automation engine. It can chain together multiple steps, like running a scan, passing results, cross-checking vulnerabilities, and summarizing the risks, all without constant human input. WormGPT, a research-focused tool that generates worm-like scripts and payloads for testing defenses. Used in a controlled environment, it helps ethical hackers simulate advanced malware and design stronger protections. FreedomGPT and Dejan-modified ChatGPT, custom versions of ChatGPT that reduce restrictions and allow broader experimentation. These are controversial, but they show how hackers push the limits of AI models. FraudGPT, a specialized tool for detecting fraudulent activity by analyzing data patterns and flagging suspicious behaviors. ChaosGPT and PoisonGPT, tools created to simulate chaotic or adversarial AI behavior, helping researchers understand how malicious actors might poison or manipulate AI systems. Beyond these, there are dozens of niche tools like HackerGPT, BurpGPT, Bug Bounty GPT, Pentest GPT, CIB GPT, and Bug Hunter GPT. Each one is tuned for specific use cases, from bug bounty hunting to penetration testing and API security. So what's the real value of all these tools? Enhanced security posture. They give ethical hackers deeper insights and faster detection so organizations can defend against threats more effectively. Operational efficiency. They automate routine tasks, freeing experts to focus on high-value analysis. Improved decision-making. By processing large data sets and combining them with threat intelligence, they help hackers prioritize vulnerabilities and choose the best mitigation strategies. In short, ChatGPT-powered ethical hacking tools are changing the game. They don't replace the hacker's creativity and judgment, but they supercharge it. The combination of human expertise with AI-driven automation is what allows us to stay ahead of rapidly evolving cyber threats. Now, let's walk through the penetration testing lifecycle, the standard steps we follow to simulate real-world attacks, find vulnerabilities, and deliver actionable improvements. Let's go through the 6 main stages. Step 1, planning and scoping. This is where everything begins. Goals are set, the scope of testing is defined, and rules of engagement are established to make sure testing is safe and controlled. Step 2, reconnaissance. Here, information about the target is gathered. Ethical hackers use public data, system scanning, and other techniques to build a profile of the target environment. Step 3, vulnerability analysis. In this phase, weaknesses in the system are identified using both automated tools and manual checks. Risks are then prioritized based on their severity and impact. Step 4, exploitation. This is the action stage. Testers attempt to exploit the identified vulnerabilities to see if they can gain access to systems or sensitive data just as a real attacker would. Step 5, reporting findings are documented in detail, including what was tested, what vulnerabilities were discovered, and how they were exploited. The report also provides clear recommendations to fix issues and strengthen security. Step 6, remediation and retesting. Finally, fixes are applied to address the vulnerabilities. Afterward, retesting is done to confirm the issues are resolved and that the system's security posture has improved. And that completes the penetration testing lifecycle, a critical process to help organizations identify, understand, and fix security weaknesses before attackers can exploit them. So that was our deep dive into hacking concepts, ethical hacking, AI tools, and penetration testing frameworks. Cybersecurity is always evolving, and the best defense is continuous learning. If you found this valuable, make sure to like, subscribe, and join me in the next video, which will be a 100% practical video.